Hey, this is your host, Electricity and Magnetism. They're like two peas in a pod. They're so closely related that we often talk about them together as if they were one force, even though really they're two separate fundamental forces of nature. You know how when you walk next to someone and they're so good looking that you can't help but notice them? Well, electricity and magnetism have a similar kind of relationship, except instead of being attracted to each other because of their looks, they're attracted to each other because of their moves. You see, electricity is all about the moves, specifically the movement of electric charges. When those charges are at rest, they set up an electric field. Just like a magnet has a magnetic field, that electric field can exert a force on other charges. This is the essence of what we call the electric force. But as soon as we start moving charges around, we generate a current. And with that current comes a magnetic field. In other words, moving electric charges, aka electric current, generates magnetic fields. That's the essence of what we call the magnetic force. In fact, these two forces are so intertwined that we can't even describe one without the other. For example, let's go back to our electric field. Turns out that if we want to describe that electric field mathematically, we need to use a tool called a vector potential. And here's where magnetism comes in. Because the vector potential is really just a different way of describing the magnetic field. So in the end, talking about electric fields is really just another way of talking about magnetic fields and vice versa. And it's not just that we can describe one force using the language of the other. The two forces can actually be converted into each other. We already saw how electric current generates a magnetic field. But if we move a magnet by a stationary current, we can do work on the charges. Which means we can convert the magnetic force into electric energy. In other words, we can generate electricity from magnetism. That's how every single electric generator works. In fact, we can take this idea even further. If we keep pushing charges around, creating a current, we can generate a magnetic field, which will then generate its own electric field, which will then generate its own current, and so on and so forth. And we get a nice little feedback loop going on. And that is the basis for how every single motor works. In the end, electricity and magnetism are so closely related that we can talk about them together as a single phenomenon called electromagnetism. And it's no wonder we do that, because together they make a pretty powerful pair. Like, take a look at this MRI machine. It uses strong magnetic fields to align the atoms in your body, so that they generate weak magnetic fields. Then, by changing those magnetic fields really quickly, we can change the energy levels of those atoms, causing them to emit radio waves that we can pick up and image. Or consider your cell phone, which uses electromagnetism to send and receive signals over hundreds or even thousands of miles. Or any number of other technologies that make modern life possible, from electric cars to MREs to smartphones to nuclear fusion magnets. These are all made possible thanks to the power of electromagnetism. So next time you see a sleek electric car or chat on your smartphone or get that perfect Instagram pic, take a second to appreciate the beauty of electromagnetism. 2. Forces of nature that may seem different, but are in reality inseparable. Thanks for watching this episode. If you want to help us make even more amazing science videos, you can join our community on a crowdfunding platform.